stayed. This is the final talk in the main room, except for the wrap-up, right before the wrap-up. And I am super excited for these guys to come on board and talk a little bit about this. So I'm going to bring up, if they're ready, Chip and Charlie from Some Global to talk about Gradle to Bazel. Let's have a big round of applause for these guys. Thanks so much.
Hey. Hi, everybody. How are you doing? Hope everything, the last talk of the night. And so, we'll try to go fast and cover things as quickly as we can here. So, first, just, quick introductions. I'm Chip Dickson. This is Charlie Walker.
Hey, everybody.
I'm going to give just this huge plug or, shameless plug to the company here. Mainly because we're a small consulting company from Atlanta, Georgia. We've been in business about 15 years now, and I'd like to say thank you for the company allowing us to get up here and talk with you guys. First, I'd like to say we're really honored to be here and excited about being able to talk, especially with, holy cow, all the groups of, the names of the companies and the people and the things that you're doing. We're honored to be here. We're not exactly a household name, so a little bit about us. Most of our customers are based in the utility and financial retail space. We've had many, many years now of using build tools, Bazel, Gradle, Maven. We're in the Bazel community experts. Building CID consulting now for about 8 years, and it's kind of an interesting story. We're really a consulting company for building applications. And what we ended up finding is we would go into a company to go build an application, and we would say, okay, where is your source control system? Where is your CI system? Where is all the things that you need in order to build something? And most of the time the answer was, what? So we kind of stumbled into this CI/CD practice, if you will, over just out of necessity is really where it came from. So at first, of course, 8 years ago, we weren't doing a lot of CD. We were doing mostly CI. But as our architectures have evolved, our tooling requirements have changed a great deal. So we have about 20 years experience doing this kind of stuff, enterprise software and that sort of thing. So we're the old graybeards and been around. Just say, I had this conversation, I don't know if he's out in the audience, but basically some poor, I call him a kid, he's not, but some poor guy had to basically listen to this conversation from Charlie and I over lunch the other day. So getting started, we're not really talking about new projects here, but I wanted to mention it just to kind of, hey, how do we get started? We do a lot of greenfield development. So in the Gradle, they have a really nice init feature. We don't use it very often, but it's there. It's a good start. Prompts really nice. In Bazel, not really an equivalent there as far as greenfield and getting started. So there is the Bazel project, which has some hooks for other languages, so kind of looking forward to seeing how that ecosystem evolves. So we start talking about, okay, how do you manage different versions, right? So Gradle has got the Gradle wrapper and Bazel with the Bazel project. I'm pretty interested in how this is going too. Especially as it may evolve with the Bazel Federation pieces and some other things. I'm kind of excited about how this is gonna move going forward. So this is probably the most interesting topic when we start migrating things. The first rule of a good, correct, hermetic build, right, is getting your dependencies right. And just had a good talk about a lot of those issues that we're talking about here. So we're going to spend a little time on this as when we were doing the conversion. This is obviously the first major hurdle that you hit when you're doing a conversion, especially from Maven Gradle. So in Gradle, right, you specify your dependencies much like this, and if you've seen it, you've seen a Gradle file, it's pretty straightforward. With the rules JVM external, you can see you can specify your rules pretty much the same way as the highlighted piece here says. So it's a pretty straightforward, here's, as far as specifying your pieces, it's pretty straightforward. So some more about dependencies, right? Gradle is a dramatic improvement over Maven if you've been stuck with Maven before. In Gradle, the highest version wins in your dependencies typically. There are other strategies that go here. You can create, it's got all kinds of features around version lock files and transitive dependencies and locking all the versions down and things like that. But one of the things that we discovered, at least in this particular build that we migrated, was that transitive dependencies could be called from, instantiated directly from other pieces of the build that had nothing to do with, or they weren't listed in the Gradle file. So, one of the things that we found as we were going through is in this transitive dependency references and piece, also is that you don't always get what you think you're going to get. It's way better than Maven, but there are sometimes some surprises. So for instance, in this build, we had a project A that depended on something, project B depended on the same thing, and when we got down to it, we were expecting 504, and we got 507. Now, to achieve hermetic builds, right? It's just hard, right? It's not hard in. I mean, it's not easy in Gradle. It's not easy in any other. So it's not easy in Bazel either. So Bazel's promise, at least in this port, is about the speed and the correctness of the build. What was nice is we found that, okay, we asked for 504, we got 504. Right or wrong, it was 504, right? So I can tell you that while I was doing this, I didn't like Bazel very much. All right. It told me all the time, I mean all the time, can't find this dependency, can't find that dependency, this is the wrong version, it really told us a lot about the build that we were migrating and how much we were taking for granted or how much didn't know about the build. So you may ask, like, why all this extra time on this, on the dependencies? In our Gradle to Bazel conversion, it was the single biggest challenge. And the getting of a wrong version doesn't always happen, but given a sufficiently complex build, it happens enough that it's something that you've got to think about, something you have to address. So the one thing I'll say is it's easy to blame the new tool, all right? That's the first thing you want to do. It's like, oh, Bazel's horrible. I can't believe it did this. No. A lot of times, the real problem is really hard to find, because what really should have happened is, based on the build structure here, right? Someplace along the line, someone found a problem, and they upgraded the version of Spring that they were using, and it fixed a problem, which your code has been taking advantage of in the other build system, right? So it wasn't either tool doing the wrong thing. It was simply, in Bazel, you know what it's doing, versus in Gradle, we didn't necessarily know how it got there. So
All right, so one of the things that we came in, that we started working with was how do I specify the Java version that I'm compiling down to? In Gradle, it's pretty simple. You specify in your build.gradle, you specify your source compatibility flag and target compatibility flag. But how do I do that in Bazel? Because Bazel, we didn't find that same thing, but Bazel is actually still pretty simple to do. You use you can either pass in through the command line a Java copt and specify your source and target, or you can put in your Bazel RC flag. You can specify it there. So that's how you specify the version that you're compiling down to. Now, what about viewing the dependency graph? Chip has talked a little bit about defining dependencies, and when we were doing our port, one of the hardest things that we had to do was figuring out all of the dependencies, the transitive dependencies, and how they worked. And so we were actually able to use these tools here in Gradle. If I want to look at my dependencies, you have a bunch of different ways. You can list your dependencies with Gradle dependencies. You can do a dependency insight and list dependencies for a single API there, or single dependency. So you have lots of different ways that you can do that. In Bazel, you can use the query. You can use Bazel query. So if I wanted to list all the dependencies of // foo, I could just do a Bazel query and deps of foo. Now there's several different ways you can output that. You can just take the output from it and read through it. You can output it to a graph, and then use something like there's some graphing tools that you can use, and it'll display the dependencies in a graphical format. So how do I, if we're coming from a Gradle file, which is what we were porting from, how do I declare a task? In Gradle, here's a simple task, just task hello, do last, and it simply prints hello. So how do I do that? How do I do that in Bazel? Well, in Bazel, I want to create a rule. I can create a simple rule here, which is basically in rules.bazel. It creates a rule and an implementation basically that just prints hello world. And in my build file, I can load that rule and run it, and it'll, in the debug output, it'll actually print hello. So, yeah, you put that build file where? So we've seen in other talks here today that where you place your build files can make a big difference in the speed of your build. In Gradle, you have a build file at your top level of your directory, and Gradle expects you to have your source files in a Maven-esque type directory structure. You can change that if you want, but by convention, you would expect to have your source files in that way. In Bazel, however, you can do the same thing. You can replace a build file to pick up everything for an individual module and have it do the same thing that Gradle does. But it's a better practice to put a build file, and they've talked about this 6 or 7 times, to put a build file at the package level. So that's how you do that. That's how we did that. So when I'm running Gradle, when I do a build, my tests just run. Whenever I call Gradle build, they just run, or I can run them separately with Gradle test. So when I run my build for Bazel, it doesn't run my test automatically. But that's because Bazel just works differently. If I want to run a test in Bazel, I just call Bazel test, and I give the path to the target. Or if I want to run all the tests, I can just call Bazel test and pass in the whole thing and run all the tests at once. So what about Spring Boot? We work in the Java world a lot, and you encounter Spring Boot a lot. In Gradle, it's just as easy as using a plugin. There's a plugin for it. You use a plugin. It's well supported by Spring, by the Spring community. It's pretty, and it's really easy to use. So how do you do that in Bazel? Well, there's no rule. There wasn't a rule out there in the Java rules for doing Spring Boot. You can use. There's an example out in the Bazel. In the Bazel code of doing Spring Boot, but in their example, it actually doesn't build out a boot jar file. It actually just pulls all your dependencies together, creates a script to run, and runs it that way, which is workable, and it works. But what we'd rather see is a Spring Boot jar that's got is well defined now. So what we did was we didn't want to reinvent the wheel, so we went on to look for somebody else surely somebody else had done this before, and we found that Salesforce, our friends at Salesforce, had created a Bazel Spring Boot rule. And we took a look at it. It was a couple of years old. Didn't work because it was with the newest version of Bazel. So we forked it, made a few changes to make it work, and now we're using that. And now so it just so happens at this conference we've talked with our friends here at Salesforce, and they have actually updated the Spring Boot rule. Thank you, and they're gonna push those changes out. So hopefully we can use that for projects moving on. All right, so how about micro profile? So if you're not using Spring Boot, you may be in the JEE community and want to use a micro profile. Well, even in Gradle, micro profile doesn't work very well. There's a few plugins for it. Thorntail is one of the plugins. It has a Gradle plugin, but it doesn't work very well. It's not very well supported. Open Liberty has a Gradle plugin, and it is updated regularly, but it still is second class, and it heavily relies on ant tasks. So, but what about the Bazel world? Well, no such luck. Bazel, in Bazel world, you're on your own. There are tools, these tools, they have documentation on how they're packaged and all. So this is kind of on our radar to take a look at building some rules specific for this. All right, well, okay, so I've figured out a way and I've built my fat jar. So what about my Docker image? So the project that we were migrating, this project that we use for this talk that we're migrating, it actually used Docker images. So it built out these Spring Boot jars, and then it created Docker images for it. So in Gradle, there are some solid Docker plugins, but they execute by using the Docker that's installed on your system. They're not hermetic, but they do work. They don't run in parallel. And it can take a long time. And they use Docker files for building. And then you publish using your installed Docker. On the Bazel side of things, Bazel has rules Docker. It's a different approach. And Bazel actually has its own container builder. It's hermetic, it's fast, it runs in parallel. And the image configured is via the rules. So it's a different approach, and it takes some planning and understanding to get it to work right. And you should know what you put in your Docker container. So, all right, and here's kind of an example of how you do it on the Gradle side. You copy your artifacts to your Docker, and then you run your task to create your Docker image. And on the Bazel side, you can see it is pretty straightforward. All right, well, how about publishing a jar file? I don't see any rules on the Bazel side for publishing a jar file, but how do you do it on the Gradle side? Well, Gradle, we can use the plugin Maven Publish, And just define the parameters. We can just tell it what Maven repository to publish to, give the authentication, and and publish. It'll publish the POM file, and Gradle has a new a metadata file that it'll create and publish with it. Bazel doesn't provide this functionality in the Java rules, so you're kind of on your own for this. The publishing part of it is kind of straightforward. It's just a bunch of HTTP calls, right? The problem is the creation of the POM files. You're going to have to do that yourself. We've had some success doing that using some Bazel common rule sets that have some POM file creation. There's also Graken Labs has also got a set of rules to it that help you do that, and they're open sourced. And I believe I heard yesterday Salesforce actually has a set of plugins or a rule set to do that also. So there's at least 2 or 3 ways to publish a jar file, rule sets out there to publish a jar file. All right, well, what about my code quality tools? Gradle has plugins for all my code quality tools. I can run spot bugs, I can run PMD, I can run check style. What do you have? How do you accomplish the same thing in Bazel? Well, Bazel uses error prone. It's built in to Bazel, and it works just straight out of the box. And you can control what is reported either in the Bazel RC file or by the command line. Now, there are also some other rules out there. There's some rules for running check style. There's also a rule for running like Sonar Cube, but specific tools require custom rule sets. But don't I need to clean the build? Gradle does a good job of keeping you from running clean, but sometimes there are times when you simply have no other choice. On the Bazel side of it, this is one of Bazel's primary goals. It's to ensure that you do correct incremental builds. Now, I'm not going to read this to you because they've went over this a bunch of times this year during this conference. But one of the things, this is one of the benefits of using correct incremental builds is you don't waste time waiting on rebuilds caused by the use of a clean command. So how do I build a war file? In Gradle, I just used a war plugin. Again, in Bazel, the Java rule set, it doesn't contain any rules for building a war file, but there's another rule set, the app engine rules. They actually contain that. So what we did was we used the app engine rules and used the Java war. Here's an example of it. So what happens if I need to do something special? If I need to do something special in Gradle, I'll use plugins or custom tasks, or I can write custom plugins. On the Bazel side, we can use custom Bazel rules. We can use a gen rule, tool chains, platforms. These are the things that we can do if we want to do something special in Bazel. Now I think I'm going to hand it back over to Chip here.
All right.
Let's talk a little bit about performance.
So first, let's talk a little bit about the project that we actually migrated. The original Gradle build produced 11 libraries, 19 microservices, each of them in their own Docker container. It's not a giant build by any stretch of the imagination. We picked this part of, you've heard migration strategy talks, you've heard other things. So we picked this piece of the build because it was in our wheelhouse. So we understood, we could look at what the Gradle build was doing, and we understood what it was doing and why it was doing it. So it was the low-hanging fruit in the project. The simple stats comparing that we're going to run here is just we run a clean build. We produce the Docker containers in both Gradle and Bazel. So no caching to get started or anything, just we ran clean on both of them, and then we just ran. It's not a good mark. Neither build, by the way, is totally optimized or anything like that. These were just as they came. We didn't spend a lot of time trying to optimize the Gradle build. That wasn't what we were trying to do. We just migrated the build and actually put the at the build file level at the same place that the build.gradle files were. So we did not start breaking it down by package or anything like that. Wow, okay, covered all that. Guess I've memorized more of this than I thought. There are definitely things in both builds that could make both of them faster, okay? In the Gradle, just looking it over, based on our experience, you kind of apply the 80-20 rule here. Further optimization of the Gradle build was going to take a lot of effort. You know, there's a lot more effort for a smaller gain in the optimization of the Gradle build. Bazel, of course, further breakdown of the build of the work units could definitely improve the speed and things like that. So with Gradle, first thing, this goes back to one of the early slides on dependencies, right? In the Gradle dependencies, we kind of went, oops, how'd that get in there? So that was kind of the first as we were trying to do the comparisons of how correct is our build based on what the Gradle side was doing. You can kind of see the two builds. We ran it first and then we ran it a second time. You can see that we got 123 tasks were up to date and it ran 19 executed tasks. That's due to the Docker plugin and it calling out and shelling out basically to the Docker run commands there. So Bazel dependencies, we got exactly what we asked for. First run, equivalent roughly. Second run, far faster. And again, that comes with the rules Docker part of this because it was cached, the results were cached. So this is not a statement on, oh, this build, this is why we did this. The actual reason that we ported this particular build had more to do with the hermeticity and the reproducibility of the build, as well as dealing with the provenance. So more security related than performance related, but it was nice to see a little speed up in some of this. So a few other things. Gradle, if you're doing a JVM language, it's a great tool. Android, the Gradle Kotlin these days is kind of the de facto Android app way you're doing stuff. Gradle builds your Java-based stack, but if you start getting outside of Java, you want to go build your Angular app along with your iOS app, along with the rest of the things that you're doing, then you're going outside of Gradle for your tool stack. With Bazel, it builds many things well. You've heard a million talks about this. When we wrote this, we didn't know what order we were going in, so I'm not going to read through all this piece. Couple of things from a JVM's perspective, right? Kotlin support is still improving and improving. Other JVM languages, you've seen talks, Groovy has got solid support. And Bazel, basically, part of the reason that we're moving projects to that is basically you get a full stack approach for a common tool. So, some of the lessons learned. It's not always the tool that's doing something wrong. Sometimes you just did something wrong. With Bazel, dependencies are definitely intentional and very precise. And that is sometimes painful coming from the way you do things in other tools, Maven or Gradle, and the way you think about, the way, I guess, the tools think. So replacing plugins from the Gradle ecosystem is not always a direct port, like for instance, the war pieces that we found here. Right, so we went looking for, okay, how do I create a war file in ruled Java? Well, there's not one. So we went someplace else and found someplace, found the other piece. So you're not always looking for something that is a one-to-one common piece. So again, this goes back to many of the parts that you need in doing your conversions or doing your port, they already exist. They're just not always lumped into where you think they might be because they apply to something else or they're more generic. Generally, Bazel just thinks different than Gradle. And that was probably the hardest thing that we did trying to approach this. Bazel kind of gives with great power comes great responsibility kind of a thing. Gradle's approach is more, don't you worry your pretty little head about that. Both have merit, but we're finding as we're moving forward that knowing exactly what our build is doing, knowing exactly where things are coming from is much more important as we build these more complex systems than the necessary, some of the ease of use that we get. So.
Well, that's great. Is that, you guys ready for questions?
Ready.
We are,
All right,
thank you, sorry.
Round of applause for Chip and Charlie. We got time for maybe one question, maybe two questions. Have anybody? If not, we can move towards the wrap up. So it's all good. I'm super excited that you've come on stage, super excited that you've come to be a Bazel community expert, and I'm super excited about the knowledge you bring to the community. So thanks again.
Thank you.
All right.
Thank you very much. Thank you.